Hello. We carry on here with demonstrating plotting exercises in qtVlm and doing that by working some examples from our workbook. And here is one example on currents. It is, we have basically two position fixes passing a buoy at one time, and then a little while later, an hour and a half later, passing another buoy close abeam. And then we have DR. We have our DR in between those two times. And the question is, how good was our DR? And if our DR was wrong, did not agree, then if we assume that difference is due to current, what was the set and drift of that current? So that's the exercise. And we have here, we're going by New Dungeness Lighted Bell Buoy 2. That's over here, right here. And that's at 9:15. Then we're on course 090M. We're at 6 knots, 6.0 knots. And then an hour and a half later, 10:45, we're going by this buoy. Excuse me. So that's our two fixes. And then we do the DR between them to see if they agree, and if they don't agree, what's the difference, and that's the current. Okay, so let's start out. This is done with pathways, and I create a pathway, and I'll call this, it doesn't matter, 9-1. 9-1, and I'm going to start from the first mark and say append. Oh, I've already, name already used. Okay, cancel. So let's demo something here. Marks management. So here's some mark. Well, let's just delete these marks here. Remove. Okay, yes. Close. Now, where is our pathways? Delete, edit, delete pathways. I got a whole bunch of them here. This must be from practicing. Close, remove them all. Okay, so now let's start from scratch. And we do it again. Okay, so again, we're demoing, learning how to use a program, and these are functions of that. So pathway, create a pathway. We'll call that 9-1, and start from the first mark and append. And so so the idea was we're going by this buoy. Let's just say we're something like right here. That's going by the buoy. And then a little later, let me just put that over here. Then I can either say stop up here, or I can hit escape. Escape key does the same thing as this. I stop. Okay. Then I'm going to move that guy to the right place. Now this I could call this a fix. I could call this a fix at what, 9:15. Oh no, well, it'll be fixed at 09:15. And you know, for this kind of plotting on the program here, it doesn't matter at all. But when you're emulating what you would do on a chart, you would definitely be labeling such things. Okay, so that's okay. And then this is going to be another fix. Actually, this is going to be a fix at 10:45. 10:45. So those are two fixes, and the other fix is the same as that one. You know, we basically have our arm around a buoy. I don't know exactly where this is, so we're not looking for 1/10 of a degree or anything here, but anyway, something like that means that that's an arm around a buoy, assuming the buoy's in the right place. That's a position fix, as if we had taken bearings to one thing or another. Okay, now that's the actual run. That's what we made good. That's what we made good. Now, what's our DR? How would we do our dead reckoning? Well, we do another pathway, create a pathway. Let's call this, what again, 9-1 DR, say. And then say, oh no, that's the pathway, okay. and then from the first mark and append. Now that's going to start right here at the same place, and that's going to come someplace over here, and I can say escape or hit this, escape. Now I'm going to give this a name, edit. This is a DR at 1045. DR at 1045, and say OK. Now where was that DR? Oh, that's what we have to figure. Now what it said is that we were going, let me bring this over, 10:45 to 9:15. That's an hour and a half run, and it says we were going 6 knots. So the first hour we went 6, second hour we went 3, so we went 9 miles in direction 090 m. So that's our dead reckoning. So now if you want to do real accurate sort of, now I can drag this around and get to 9 is about here. 9's about here. See if I go up a little smaller, 8, and go just turn to 9, right? And now that's 89. I got to just then come down a little bit like that, and then go out a little bit to get to 9 again. Down. Okay. So that looks pretty good. Now that says we've plotted 9, well, that's close enough. 9 miles at that. Okay, now, so this is our DR at 10:45. This is a fix at 10:45. So if it's a current, the current's flowing this way, and now we can figure out what it was. So I need another pathway between here and here. Now one way to do that is I can just go in here and say append. That means add another one at the end, and then just click this. Okay, and then escape. Now here's our answer that we're after. What do we get? 1.5 nautical miles in direction 0615 m. Let me show that again. Okay. So 1.5 nautical miles, and we were 1.5 hours in this run. So that means the current that would take us over there is 1.0 knots. And the direction would be 0615 m. But technically it asks for the set of the current, and sets of currents are always given as true. So we would have to take our variation of 20 degrees and say that it's 81 m, 81.1 degrees true. So that's our answer. What's the book give here? Oh, we got the same speed. We got a very slightly different current, and I don't know which one is right. See, because we had to choose what's it mean we're passing that buoy close by. That's going to be, and also we're not navigating to within 1 degree in any sense. So that's the exercise of how you would take 2 position fixes and the DR between them, and then figuring when they don't agree, what's a current is that could account for that difference, if it were just current.